Okay, so I'm going to go through the red questions, which are question 14, 15 and 16. So starting with number 14, this one says the ratio of the 5th term to the 12th term of a sequence in an arithmetic progression is 6/13. So what that straight away tells me is to get U5, so the 5th term, it would be 6/13 of U12. And then it carries on to say if each term of the sequence is positive and the product of the first term and the third term is 32, so U1 times U3 equals 32, find the sum of the first 100 terms of the sequence. So straight away here, what I can do is start swapping the U's for expressions with A and D. So the 5th term would be A plus 4D, and U12 would be A plus 11D. Remember, that's because when you do an arithmetic progression, you start with A, and then it is A plus D, then A plus 2D, etc. So it's always one less D than the term that you want. And then I could use this over here as well. So U1 we know is A, U3 would be A plus 2D equals 32. So I've got simultaneous equations here now, so I need to rearrange and solve. So what I'm going to do is times by the 13, I think here, so 13A plus 52D equals 6A plus 66D. This one here is going to become A squared plus A2D. So I'm just going to leave that one for now to see if this one simplifies a bit nicer. So if I take away 6A, I get 7A. And if I take away 52 from 66, I get 14. So that's quite nice now because they both divide by 7. So I found out that A is 2D. So if I swap now the A's up here for 2D's, I'm going to get 2D times 4D equals 32, which is 8D squared equals 32. Divide by 8, it's 4, square root it, and we know it's going up the sequence, it's positive, so it's going to be the positive square root because the difference would have to be increasing and positive, so D is 2. Therefore, that means A must be 4. So now I've got those two values, I can find the sum to 100. So sum of the first 100 terms would equal 100 divided by 2 times 2 times 4 plus 99 because it's n take away 1 times 2 for D. So that would be sorry, I just typed it in wrong. 10,300. Okay, number 15. This has two parts. Part A, find an expression for the sum of the first 20 terms in the sequence, and it gives you the start of the sequence, so ln x plus ln x to the 4 plus ln x to the 7 plus ln x to the 10, dot, dot, dot. Okay, so we can see straight away what A is, it's ln x. And it's a bit less clear what D is. So remember, to find D, it would be the difference between the next door terms. So it would be like doing ln of x to the 4 take away ln x. If you remember from our log rules, you can bring that 4 down. So we actually get 4 ln x take away ln x, which if you have 4 and you take away 1, you get 3 ln x, which is the same as ln x to the power of 3. And you can see that this would work for the other ones as well, like if you did this one to the power of 7, take away this one to the power of 4, that would also work, so that looks good. So the sum of the 20 terms, well, it would be 20 divided by 2, then 2 times a, which is ln x, take away 19 times d, because it's one less, remember, than the terms, so ln x 3. And we want an expression, so we're probably going to be left with the x's in there. So I'm going to have 10 at the front, and then in order to simplify these really, it's going to make sense to simplify them a little bit. So I'm going to keep this as 2 ln x there, and then this one I could bring the 3 down, so 19 times 3, oh sorry, that should be a plus there, not a minus, be 57 ln x. Add those together, you get 10 times, it'll be 59 ln x, which is 590 ln x, which could also be written as ln x to the power of 590. Now part B says, hence find the exact value of x for which the sum of the 20 terms equals 2,950. So what we want to do is put this equal to, I'm going to put it equal to 590 ln x rather than the power one, because then I can straight away divide by 590, which gives us 5. So ln x is equal to 5. Okay, last one. Find the sum of all 3-digit numbers, so 3-digit numbers, that are multiples of 14 but not 21. So let's start looking at the digits that it could be. So the first 3-digit number is 100, and we want to kind of see what number would divide by 14 near that. So if I did 100 divided by 14, I get 7.1. So it looks like 7 times 14 is going to give me 98. So if I add 14 on, I'll get my first multiple of 14 that is over 100, which is 112. It's going to go 112, add 14, 126, again 140. Right, now that's going to carry on. And then at the other end of the spectrum, we'd have 1,000 would take us over to 4 digits. So if I divide that by 14, I get 71.42. So 71 times 14 is 994. So that's going to be like the biggest term we've got. And if we took away 14 a couple of times, you could get a couple of those numbers. Okay, so all of these numbers added up would be all the multiples of 14, but we do not want to include the ones that are multiples of 21. So for these numbers, if we check them, 112 is going to divide by 14, but not 21. And 126, however, will divide by 21. And if I just go through and check the next one, 140 doesn't work. Let's try 154, because that would be the next one. That wouldn't work. The next one after that would be 168. That one does work. So if I just put 168 in here, that one does divide by 21. So it looks like it's going to be, if I put this one in here, every 3 will divide by 21. And we can kind of look at the end ones as well to see when that would stop. Okay, so that would be the last one that divides by 21. So we've kind of got two sequences of numbers here. We've got the first one, which includes all of these numbers here going up in 14. So I'm just going to rewrite that down. So it starts with 112 and it goes up in 14s. It goes like this. Dot, 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 to 994. And then we've got a second sequence within that that starts on 126, goes up in. Now remember that it's going to be 14, 14, 14 to get to the common difference between each one. So we could just do 168, take away 126, and it goes up in 42s. So this sequence would be going 126, 168, dot, 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 all the way up to 966. So we have to do the sum of these terms, take away the sum of these ones. So go to 1 and 2. Now for number 1, we want to first find out how many terms are in the sequence. So we want to find out what n is, again using this one, this what we learned before. We want to find what n is. So A is 112 and D is 14. So if I take away 112, 882, expand the bracket, add on 14, so 896. And get n is 64. Okay, and that means then there's 64 terms in that sequence. So the sum of the first 64 terms would be 64 over 2, and we could use the a plus l one here because we know the last term, so 112 plus 994. Which is 35,392. Right, that is one number. Now we've just got to do the same for the second sequence. So last time was 966 this time, and the first one's 126. Common difference is 42. We get 840 equals 42n, take away 42. So you keep then solving, so add 42. We get n is 21. So the sum of the first 21 terms of that sequence, oops. And again you can use a plus l. Get 11,468. Sorry, I meant 66 on that one. So to find the 3-digit numbers that would be remaining, we would do 35,392, take away 11,466. Which leaves us with 23,926. Okay, I hope that helped you with the more challenging red questions.